Assalamualaikum and good afternoon everyone. So last week you have been introduced to the MATLAB environment where you were shown how you can start your MATLAB program and also solve simple problems in the command window. You were also shown how to or what is the function of these various MATLAB windows and how to name and use variables, understand the order of operations, and also understand the difference between scalar array and matrix calculations in MATLAB. So today we're going to look further into arrays and matrices. The topic outcomes is to understand the difference between scalar array and matrix calculations in MATLAB, manipulate matrices, extract data from matrices, and finally solve problems with two variables. So this is just like a revision because I remember that I have shown to you last week. So in order for you to create a vector, or in this example we want to create a row vector, you can just type the variable name, enclose the elements inside these square brackets, and separate the elements by using a space. Alternatively, you can also use a comma to separate between elements. We will use a semicolon to create a new row. In this case, we want to create a row vector. And let's say if we want to create a 2D matrices where it has 3 rows and 4 columns, we can just type like this, separate the elements by using a space bar, use semicolon to indicate we want to create a new row, followed by 2, 3, 4, 5, a semicolon, and then just hit enter. Alternatively, it is much easier for you to keep track of how many values that you have entered into a matrix if you enter each row on a separate line. Okay, so for example, the first row contains these 4 elements, which is 1, 2, 3, 4. Type semicolon, hit enter, and then continue to the next row of elements, semicolon, hit enter, 3, 4, 5, 6, the last elements of row, close the square brackets and hit enter. Sometimes you might want to create vector with specified constant spacing between elements. Okay, so for example, we can use the colon operator in order to create a vector with constant spacing. For example, we want to create this row vector of b from 1 to 5. So typically student will type like this. Oh, sorry, I forgot to. But alternatively, you can use the colon 1 to 5, so that MATLAB will automatically create this row vector with 1 spacing. Okay, so by default here, 1 to 5, the default setting or the default spacing is 1. So if we want to create another spacing, for example, with C, 1 is the first number, and between 1, the next number of 1 will be increased by 2. Okay, the middle one here is the increment or spacing between the numbers, and then use the colon operator again, and then this is now the last number of the vector. Alright. Another method to create a constant space vector, okay, I just shown you the first one, which is we use the colon operator. So the second one is you can use this linspace function. Okay, to use linspace function, what you have to do is just type out this command on command window. Okay, so let's see, maybe we use this variable name d is equal to linspace. Linspace means linear space. Okay, this one, right after e, do not put space, open the round bracket. Okay, so make sure it's shown you the guide right here. So x1 means you have to identify or type your first number followed by x2, the last number, and n is how many number of elements that you want to create that vector. Okay, let's say we want to create a linearly spaced vector starting from 1, and the last number of that vector will be 10. Okay, and then how many elements will be inside the array is 3. Okay, so MATLAB will automatically produce this linearly spaced. Okay, the linearly spaced means the spacing between, or the gap between the first number and the second number is equal to the second number and the final number. Let's say if you want to use, or we want to generate the logarithmically spaced values between 2 powers of 10, the function that we can use is log space. Okay, to do that, let's say I assign a variable named e to create a logarithm space values, okay, using this log space function, and then you just open the round bracket. It will show you this guide where the a is the a is the number of powers of 10 that you want to create. Okay, so a here, if I type 1 comma 3, the middle is where I specify the the last number. Okay, and then the last one is how many elements that MATLAB should create for this row vector e. Okay, and then it will yield this row vector. So the number 1 here just means that the first number is 10 to the power of 1. The final number would be 10 to the power of 3, and then 3 is how many elements that MATLAB should create, which is 1, 2, and 3. When you are using the log space command, one thing that you must remember is the way you enter the input. Okay, so you should enter the initial, this one is the initial, and final values as the powers of 10. Okay, not the actual values that you want. Okay, because if, okay, for example, you enter the input for the log space command as the actual input that you want, what will happen is you will not get this one. Okay, but you will get another values of vector. Okay, INF here means infinity. You can include math operations inside a matrix definition statement. For example, here a 0 pi over 10 is the increment, and then the final number is pi. Okay, pi is the value of 3.14. Okay, pi is the value 0.3142. Okay, sorry for the mistake. Right, next. Next, let's look at how we can do mixed calculations between scalar and array. Okay, so you can use matrix in many calculations with scalar. So I hope by now there is no confusion when we perform addition and subtraction, because it is straightforward. But when we are dealing with multiplication and division operation, there is a little difference. So in matrix mathematics, the multiplication operator has a very specific meaning. So it means, let's try out this example. First, let's define a row vector of A. Look, I just used the shortcut of using this colon operator. And then now I want to do addition procedure between A with 5. So I want to create a row vector B, but I want to increase each elements of row vector A with 5. So I just type A plus 5. So I get a new vector assigned to a name B. So I can add up these two vectors A plus B, but okay, I can do that only when it carry or it has the same number of elements. Okay, so notice here, let's say I have another row vector of C, okay, from 7 until 11. 7 until 11. Okay, now let's say if I want to add a row vector A with C, A plus C, what happen is it will trigger this warning. Okay, matrix dimension must agree. So it means that MATLAB can only do addition between row vectors, or between matrices, or row vectors, or column vectors, when it has the same number of dimensions. In this case, this row vector had 3 elements or 3 columns. This row vector also had 1 row and 3 columns. So I can do operation between A and B. I can do addition operation between A and B, but I cannot do addition between B and C or A and C, because okay, one of them had different dimensions than the other one. So let's try multiplication. Okay, so multiplication between array is performed on corresponding elements if we use this dot followed by the multiplication operator. Okay, for example, let's try to multiply vector A with vector B. Okay, so type A dot multiplication operator B, hit enter, and then you will get the answer. So based on what command window shown us, we know that when we do multiplication, this dot multiplication process, what happened is MATLAB perform element by element multiplication between A and B. So 1 multiplied with 6 is 6, 2 multiplied with 7 is 14, 3 multiplied with 8 is 24. Okay, how, let's say, what happened if we just don't use this dot operator prior to the multiplication symbol? So we just type A multiplied with B. You will get this warning which shows that arrays A and B are not the correct size for matrix multiplication. Why? Because matrix multiplication requires, so let's try create another one. Okay, for matrix multiplication to occur, it need, look, now I just define, look, my A, now my B, my A is a row vector, my B is a column vector. So with this, I can just do the normal multiplication between two vectors. Okay, just like what you have learned in mathematics. Okay, so you must understand that for you to do array operations is any multiplication, division or exponentiation involving row, vector, column, vector or a matrices. Okay, you must use the dot operator prior to the operator symbol. Okay, because dot operator means that it will do. Okay, what if you try A multiply with B now? Okay, because it cannot do the element by element operation, so it needs C. Okay, and maybe we try another one. 6, 7, 8. Okay, so now I want to do element by element multiplication between C and between A and D. Okay, so this is element by element multiplication between A, 1 multiply with 6, you get 6. 2 multiply with 7, you get 14. 3 multiply with 8, you get 24. Okay, that is the meaning of this dot operator. Now, let's try this example where involve array calculation. So, assume you have a list of angles in degrees that you would like to convert to radians. Okay, first what you have to do is put the values inside a matrix. So, let's type it out. 10, 15, 70 and 90. I use semicolon at the end of my command to suppress the output. So now this is the radians formula. Degrees multiply with pi divide by 180. So I can easily get the conversion between degrees to radian. So either the multiplication or dot multiplication operator can be used for this problem. Okay, why? For example, the second time I use dot before the multiplication symbol, I also get the same results. Why? Because this operation involve the calculation between scalar, this one is scalar, and single row matrix. Okay, so when the operation involve with a scalar, you can not, okay, you can drop using the operator, the dot operator symbol. Okay, how about pi? Pi is a built-in number, okay, where MATLAB store the value of pi. Okay, the value is 3.1416. Pi is actually an irrational number, so it cannot be expressed exactly with a floating point representation. The MATLAB constant pi is actually an approximation. Okay, this one, it doesn't fix at this 3.1416. Okay, because it depends on my formatting number display. So if I'm currently on format short, so format short will show the default lah. This is actually the default setting up to 4 decimal places, but if I change the format number to format long, my pi had a very long decimal places. Okay, so that's why it is called a floating point. It's actually an approximation. So if you type sine pi, what happen is MATLAB will returns a very small number. Alright, so let's clear my command window and continue. Okay, so now let's say you have the degrees earlier. Okay, so maybe because I have cleaned, do I have the degrees? Yes. So here the degrees is shown as in one row. Okay, so if it is horizontally, so it is called a row vector. So I can convert this row vector to become a column vector by simply adding up this transpose apostrophe at the end of my variable name. So it will become like this. Okay, so you can use this transpose operator to easily create tables. Okay, to do that, this is my variable name. Okay, it could be table 1. It's not a function to create table. Okay, this is just the variable name which I name as table 1. Equal is the assignment operator, the square bracket obviously, degrees transpose, because my degrees is currently in row vector, comma, radians, also apostrophe, close the square brackets. Okay, my command window shown like this because of the size, the font size. Okay, let's get it back to format short. Yes, so you will get this, okay, table, sort of table where the first row here 10, 15, 17, 19 is the value of degrees, and the first column and the next column is the value of that degrees when it is converted to radians. So alternatively, okay, the transpose works on both one-dimensional and two-dimensional arrays. So let's say this is the table 1 earlier, so I can transpose it back. Okay, so it will become from 2 column into 2 rows like this. Okay, so you can also double click on that workspace variable name. This is table 1. Okay, oh maybe I forgot to, it is stored in answer variable. Yes, so this is first row and this is the second row. Now how to change our number display. So as I told you before, I just shown you how I can format my numbering display. But I want you to understand that MATLAB had this scientific notation. Okay, so although you can enter any number in decimal notation, is it actually not the best way to represent a very large or very small number. For example, you know that the Avogadro's constant is is 6.022. Exponent here means 10 to the power of 23. So exponent 23. So let's say you have an iron diameter of 140, exponent, kalau kita nak letak 10 kuasa negatif, so E negative 12. Okay, and then it is important, okay, when you are specifying, okay, this exponential value, to remove or do not insert blanks between the decimal number and the exponent. Okay, why? Because MATLAB will interpret it as, okay, let's try out, as two values. Okay, MATLAB don't understand and it will trigger this error lah, or warning. Now let's move further into how to create matrix. So you already know how to create a scalar, a row vector, a column vector, so it's now easy. Okay, so let's try out to define all these A, B and C. Okay, so A, this one, it is again a scalar. B is a row vector of two elements, where you can separate the elements by using comma, or you can separate the element by using space. See, here is where you create a 2D matrices that have 3 rows and 3 columns by using semicolon. Okay, so the next set of number that I'm going to type will be the second row. So second row, maybe I want to separate the elements by using space, and then this is the last row. Okay, or you can also enlist it on a separate line like this. 0 0 enter 1 1 0 enter 1 negative 1 0 enter 0 comma 0 comma 2 close square bracket enter. Okay, let's say you are typing a really long line. Okay, you can use this ellipsis, which is the 3 dots here, to continue a definition onto a new line. For example, 1, 52, 64, 197, 42, negative 42. 55. Okay, so you have all the elements 152, negative 42, 58. Alright, so this one, if you double click on the F variable, is actually a one row vector, okay, which has 10 elements. So now this is the difference between a scalar, vector and also 2D matrices. Okay, how? To define a matrix using other matrices as components. Okay, let's check whether I have the B number again. Yes, so now I want to define a matrix B, but okay, instead of 2 elements, I want it to have these 3 elements. So I just specify the first elements here, and then for the next one, I just want to include the variable name of the row vector B that I have created earlier. Okay, or what I can do is, maybe I want to create this, okay, a 2-row matrices, where the first row is this element and the second row is the elements of S vector. Okay, so it makes our work much easier, isn't it? So now how I'm going to show you how you can index into an array to change a value of that array. Okay, let's say for example, I have this row vector of s. Now I want to change this second element of row vector s from 1.5 to 1. So to do that, this is called indexing. So s open bracket 2 here indicates the number of elements that I want to change. So I want to change the second elements of row vector s into 1. So this is the currently the latest elements of row vector s. So maybe instead of 3 elements, I want to add another element. So I want to change the row vector s to include another element so that it makes 4 elements vector. So to do that, I can also use the indexing method. So s4 is the fourth element of vector s, which is currently we don't have any. So I just type 5.5, and now my latest elements of s is this one. Okay, so I start with only 3 elements, change the second element into 1, and then finally I add a final element or a fourth element to row vector s by using this indexing method. So let's say if we want to add an element outside the range of the original array. So when we do that, for now I know that the row vector s only has 4 elements. So if I index or I add an 8 elements, okay, element yang ke-8 ke dalam vector s, what will happen is MATLAB will automatically added a value of 0, okay, for the missing elements information. So untuk elemen yang ke-5, 6 dan 7 ni, MATLAB akan automatically added a value of 0. Now let's try. This is more on colon operator. So colon operator have these 3 different function. First, I've shown you how we can use colon operator to define new matrices. We can also use it to modify existing matrices. Okay, this is the first one is done. Okay, now I'm going to show how we can modify existing matrices and also extract data from existing matrices by using a colon operator. Okay, to do that, I need to specify or define a row vector of h from 1 until 8. Okay, this is for defining new matrices. And then user specified matrix. Okay, it's very easy. This one I've shown early of in early of this video. So time from 0, this is the gap. Okay, and then this is the final number. Okay, so specifying that I specified here is 0.5. Okay, this one without the middle specification number, the default spacing is 1. Okay, and then you can use it to represent an entire row or column. Okay, let's say I have these matrices of M, which consists of 1, 2, 3, 4, 4, 5. Second element is 2, 3, 4, 5, 6, and then third element is 3, 4, 5, 6, and 7. Right. If I want to extract, okay, I want to extract all the rows in column 1, mean this one. Okay, I want to extract all number inside column 1. What I can do is here I assign the result of extraction into variable name x. This is what matrices that I want it to be extracted from. Okay, so from M here, extract with colon operator, it means that it will extract all the row. Okay, semua dia akan, colon operator ni bermaksud semua. Okay, di mana dia berada yang membezakan sama ada dia nak extract semua row atau semua column. Okay, jika dia berada on the first input, okay, kita tahu matrices kan, okay, dia ada macam ni, koma, yang ni kan, yang ni first field, yang ni second field. Okay, if the colon operator is specified on the first field, yang ni akan indicate row specification. Okay, so here if I want to extract all rows, tapi which column? Okay, let's say column 1. Okay, what if I want to change it to column 2? Okay, maksudnya saya nak 2, 3, 4 ni ya. So, okay, what if I want to change it to ni, kolom yang keempat. Okay, so tukarlah kolom number. So, yang tukar hanya kolom number, tapi bila colon operator berada di input yang pertama, okay, dia akan extract semua row. Ni row kan, semua row. Okay, next part, let's say I want to extract all the columns in row 1. Okay, ni row 1, saya nak extract row ni. Jadi apa yang saya boleh buat adalah assign it to a variable name. This is my matrix variable name. So 1 is row. So always ingat, the first field indicate row, the second field indicate column. So from row 1 extract row 1, lepas tu all column. Okay, okay, so my earlier example is quite easy because kita hanya extract satu row or one column, one at a time. So what if, okay, still use the same example of matrix M. What if I want to extract all this? Okay, these 2 rows and all columns. Okay, all columns and all rows between row 2 dan row 3. Okay, apakah command yang kita perlu type? Okay, assign it to a variable name W, and this is my matrix variable name, matrices name. And then I want to extract, ingat tak saya cakap, the first field indicate dia punya specification untuk row. Okay, jadi saya nak extract dari row 2 sehingga row 3. Jadi 2 sehingga 3, comma. Okay, field yang kedua is for you to specify the row. The column. Okay, jadi daripada row 2 dan row ketiga, saya nak extract ke semua kolom kan. Ini kolom yang menegak ni kita panggil kolom. Row 2, row 3, semua kolom. Jadi semua kolom saya boleh guna simbol colon. So saya akan dapatlah ini. Alternatively, mungkin saya hanya nak bahagian yang kecil ni sahaja, 5, 6, 6, 7. Jadi what I can do is, okay, instead of using colon operator here, what I can do is I can type, because I know ini adalah kolom yang ke, ni kolom pertama, kolom kedua, kolom ketiga, yang ni kolom ke-4 dan kolom ke-5. Okay, jadi ini 4, 5. Hit enter. You can also use the colon operator to transform this matrix into one really long column. Okay, so just type it like this. It's just change to this really long column. Okay, next will be more on indexing techniques. Okay, indexing techniques is a technique where we used to identify an element in a 2D matrix by specifying the row and column number. Okay, again we use our matrix M as reference here. For example, M, this is a really long column of M. Now we want to identify element M at row number 2, we know row number 2, and column 3, okay, which is 4 here. Okay, or right, so you just type M2 is kolom kedua. Ni kita nak identify elemen apakah yang berada di tempat ini, at this location. Okay, dalam matrix M, location dia row yang kedua, ni row kedua, kolom yang ketiga. Okay, kolom yang ketiga. Apakah elemen itu? Yes, dia akan yield the answer as 4. Or you can also use a single value indexing. Okay, indexing ni works for row and columns kan. What if you want to use a single value indexing? Okay, jadi bila you type M8, okay, macam mana kita tahu ni dekat M8? Kita tengoklah dekat sini 1, 2, 3, 4, 5, 6, 7, 8. Okay, kita kira count from top to bottom. So M8 would be the same answer as M23. Okay, kedua-dua command ni akan menghasilkan, akan yield you the same results and also menunjukkan results yang sama. So macam mana dia count? Okay, so untuk MATLAB matrices, okay, cara dia mengenal pasti elemen number tu, dia akan count. So let's say if it is a 2D matrix that have 3 rows and 5 columns here, it will count from top to bottom and then continue to the next column. Okay, jadi ini adalah elemen pertama, kedua, ketiga sampai habis. Bila dah habis, dia akan continue elemen keempat from the second column. 4, 5, 6, continue lagi 7, 8. Okay, that's why M23 adalah sama dengan M8. Okay, next, you can use the word N to signify the last element in the row or column. So let's clear my comment window, and then this is M. So I can identify 1 N. Okay, so maksudnya saya nak MATLAB to tell me what is the element on the first row but the last element on the first row. Okay, what if I type N? So MATLAB, please tell me what is the element on the last row and also last row and also last column. Okay, last row, last column. And if I type M N, okay, I want MATLAB to let me know what is the last element in the single index designation scheme. Okay, so single index would probably this one kan. So the last element will be this number 7. Okay, that's about the basic of array and matrices. Next, we will continue on the problems with 2 variables. Okay, so far, including last week, we have do calculation that only included 1 variable. Okay, however, many of the physical phenomena can vary with many different factors, so we need a strategy to determine the array of answers that will result with a range of values for multiple variables. So you already know when you do multiplication between scalar, you also get the scalar results. Multiplication between scalar and a vector will give you the vector results. When you multiply 2 vectors together, okay, the vector must have the same number of elements. So let's say x vector here must have 5 elements. Why? If it is 3 elements, then MATLAB cannot do multiplication operation between them. So array multiplication give a results the same size as the input array. So if x is 1 until 5, it has 5 elements. And y also have five elements, but you define y using the lean space method. So the results of the multiplication operation also have these 5 elements. The results of element, okay, inside MATLAB, okay, the array multiplication is actually hasil darab inilah. So 1 darab 1, 2 darab 1.5, 3 darab 2, 4 darab 2.5 dan 5 darab 3. So hanya ada 5 number of elements sahaja kan. Okay. Tetapi bagaimana, okay, what if we want to create atau we want to map the two vectors onto a 2D grid? Maksudnya kita nak hasilkan juga walaupun kita punya input ni, for example, input kita adalah 5 elements kan, and then our next variable 1, 3. So we know kita tak boleh buat multiplication between them, okay, kita tak boleh because the size doesn't atau the dimension doesn't match. Okay, nampak tak boleh kan? So tapi kita nak buat juga multiplication between this. Okay, boleh, tapi kita kena gunakan this match grid function. Okay, cara nak gunakan dia adalah kita akan define yang the first part ni saya, okay, yang sebelah kiri ni saya define new variable name. So new underscore x, new underscore y, new variable name untuk x dan y. Okay, sekarang ni saya dah define kan x dan y. X dan y will be my old variable. So define new variable name, assignment statement, type mesh grid function, open round bracket. Okay, this one you identify atau you specify the old variable yang you nak map. Okay, sini saya nak specify yang lama ni lah, x dan y. Jadi saya hit enter. So saya dapat lah, okay, x dan y dia sebenarnya 1, 2, 3, 4, 5 je, tapi it is map, okay, supaya dia menghasilkan structure atau dimension, matrix dimension yang sama, iaitu 3 row 5 column. Sebab apa saya nak buat macam tu? Okay, so that saya boleh buat multiplication kan. Saya nak multiply. Bila macam ni saya tak boleh multiply. So sekarang bila saya nak multiply, always remember that you have to use the new variable name. So new underscore x multiply with new underscore y. Alright. So if you somehow feel that this video is quite fast, maybe you can pause, okay, sambil-sambil type on your command window. Okay, now let's look at this example. Okay, so we want to calculate the distance to the horizon. So basically this is, okay, the circle here is the earth, okay, and then you have this height of a mountain, and then we want to calculate this one. So imagine that you are standing here, you are standing right here, okay, this is you, and you want to calculate the distance from the surface of the earth until the height of the mountain. So it's basically the straight line here. Okay, so this is, since this is a triangle, so you can use the Pythagoras theorem to solve. Okay, so this is the unknown that we want to find out. This is the radius of the earth from here until here, the radius of the earth, and this one here is radius plus the height of the mountain. So okay, the problem, as I told earlier, find the distance to the horizon from the top of a mountain, on the moon, and on the earth. The input, okay, these are all the inputs that you have. So I have actually simplified it for you. So this is the information that you have, which is first radius of the moon, 1737 kilometer. Radius of the earth is 6378 kilometer, and the elevation of the mountain, okay, from 0 until 8000 kilometer. Output is what is the unknown that we want to know, which is the distance to the horizon in kilometer. So first, do not strictly jump into MATLAB and type your command. First, you have to try to solve it using hand solution or manually. Solve it manually. So we know this is the relation that we can get by using the Pythagorean theorem. And then to calculate D, okay, is equal to h square plus 2 multiplied with r multiplied with h and square root. And then by using the radius of the earth and 8000 meter mountain, okay, remember that 8000 equal to 8 kilometer. So just plug in the value into this equation, and then you will get the distance as 319 kilometer. Now after only you have get the solution, then you can type this solution in the editor file. Okay, so to do that, let's bring on my editor. Okay, so we'll type solution to example 1. So the first thing that you have to do is to the green fonts is the comments or the description, okay, of what the script will be about. So we want to find the distance to the horizon. Next, define the height of the mountains in meters. Okay, I always start my script with clear CLC, so that every time I run the script, okay, I'll get a new answer, the answer lah. Okay, so clear is to clear out my command window. CLC is to clean my variable inside the clear is to clean my variable inside workspace, and CLC is to clear my command window. So I can use format bank. Format bank is when I want it to be up to 2 decimal points. Okay, then I'll first define the height vector. Okay, assign it to a variable named h. So it was from 0 until 8000. Okay, it doesn't specifically mention the spacing, but I think the appropriate spacing would be 1000. Next, we'll convert meters to kilometer, okay, for the h. So new h is equal to h divided by 1000. Okay, so I hope you will not be confused by this command. So earlier I have this h, and then now I re-updated, okay, the h value 2 kilometer. Next, we'll define the radius of the moon and earth. So radius of the moon is 1737 kilometer, and 6378 is the radius of the earth. 6378 kilometer. Now what we're going to do is we will map, okay, since you can see on this workspace folder here, window here, that h size is 1 times 9, while the radius size is 1 plus 2, so it has different dimensions. Okay, so because it has different dimension, we need to map the radius and height onto a 2D grid. Okay, otherwise we cannot perform multiplication between h and radius vector. So to do that, first I will specify a new variable name. Okay, I just simply use capital R and capital H, and then type mesh grid function, open round bracket. This is, okay, it is the corresponding variable name of this new one. Okay, radius and comma h, close the round bracket, and then finally we'll start calculate the distance to horizon. So d is equal to square root. Okay, sqrt is for square root. It is a built-in function. We look more onto built-in function on the next video. H square plus 2 multiply with h. So if you want to do power of 2 or power of 3, okay, you need to enter dot operator, okay, before you write the operator symbol. So 2 multiply with h. Okay, this one I don't need to use operator because the operation is between vector and scalar. Okay, dot multiplication operator. This is the new variable name. Close, and then you can save, or usually use this transaction. Okay, so you will get this answer. So the final answer is this one, 315.55. Okay, because the first row indicate this is the d, okay, that we want to find out. This one, okay, on this column, 319.55. so it actually let's look at our slides. Okay, okay, so it mesh with this final answer, okay, that we calculated manually. Okay, so now let's try out to do this to practice exercise. Okay, so we continue using this editor script. Okay, so here, okay, so this is my example solution. So I want to create a new one, so I'll just edit, insert a section here. Okay, under editor tab, insert a section. So this is to solution to practice exercise 1. Okay, so the first question says that the areas of a rectangle is you can calculate using this formula. So it asks you to find the areas of rectangles with a length. Okay, so we have the length 135, and next we define the width as 246 So obviously it has different size. One had 3 elements, the other one had 4 elements. So you know you have to map onto 2 grid using mesh grid. So to do that, you should This is the new variable name, and is for length and width. Okay, this is the corresponding variable, the old corresponding variable. You will make sure that you will have 12 answers. Okay, let's try out our answer. So run section. And then calculate area. Area is equal to the new variable name. Okay, run section, and then you will get 12 answer. Okay, for each 12 answer here for the area. Alright, let's proceed to the next one. Practice exercise 2. So you were asked to calculate the volume of a circular cylinder. It gives the information for radius. So radius. Oh wait, I want to clear CLC first, and then define the radius vector from 0 until 12. Okay, but it mentioned here that you have to increase the dimension of radius by 3. So insert 3 in the middle. Next, height from 10 to 20. Increase the height by 2 meters. So specify the increment in between or in the middle. Next, we'll calculate volume. So first, let's check the size. Does it match? Okay, so here. Okay, so you notice that we have two different sizes for heights and radius. So obviously, you need to map it using mesh grid. Calculate volume by we map it onto 2D grid first. Okay, so it needs new variable name, and also for h mesh grid all ones. Now only you can calculate area. Sorry, should be volumes. Pi multiply with radius r square. So it is the new variable name, red square. Okay, notice every time you want to do power of 2, power of 3, you should use dot operator followed by the symbol for power. Multiply with pi r square multiply with h. Okay, let's check this. The solution. Okay, notice I make some mistakes here. It needs the multiplication symbol. Right, so I get the answer for volumes. So it have 1, 2, 3, 4, 6 row and 5 columns answer. Right, that's it.